Hi, Year 10. We're back into our next part of differentiation. We're on to 8G, the chain rule. If you have not done up to 8G, you need to go back and finish all of that before you can move on to here. Also noting that we will have our final year assessments coming up soon. We're now about to start week 4, so we've got about a month to go, and there's a fair bit of calculus to go, so you need to feel pretty confident with this. So let's work through 8G. Okay, so what we're going to have a look at, and we're working from our normal textbook, is the chain rule. A chain rule is a way of differentiating a composite function. So if you have a look at our function down here, not only do we have something to the power of 6, but inside the brackets we have something that has a power as well. So if we were to straightforward differentiate that how we normally would, we'd be stuck with something inside that wouldn't work the right way. So what we're going to do is we're going to use this rule here. In finding our first derivative, or our dy dx, we're going to do two parts. So we're going to assign a letter u, and we're going to work out differentiation a little bit different to what we've been doing so far. Our normal differentiation will still be used for simple ways and simple functions, but for this one we need to do it a little bit differently. So we're going to go part A. What I'm going to do is I'm going to let the part in the brackets be called u. So I'm going to let u be a new letter. I'm just assigning a value to my x squared plus 1. So what my y is going to be equal to, or my function is x squared plus 1 to the power of 6, but I've assigned the part in the brackets to be a u, so what my y is going to be equal to is now u to the 6 in terms of u. It's also equal to x squared plus 1 to the power of 6 in terms of x, but I've also got a value for it in terms of u. Okay, so we need to think about what we are doing. So originally, when we had a function equal to, for example, y is equal to x squared, when we worked out dy dx, we were looking at the first derivative of y in respect to x. So dy, we've got y on this side, over dx, we've got x on that side. And that would be equal to 2x. So thinking about what we've done there, what we can now look at here is we can look at a du dx. So du, u's on this side, and it's on the top. X is on the right side, it's on the bottom. So I can differentiate this u with respect to x. And what I'm going to end up with is 2x. Same rule as our simple differentiation. The 2 comes down the front, 1 comes off the power, and that 1 at the end there disappears. And if you have a look at our rule here, that dy dx is equal to dy du times du dx. I've got one part here, I've got a du dx. So in this rule, when I'm breaking up my dy dx into these two terms, what I'm basically getting is a du dx's are cancelling out each other, and I'm still really getting a dy dx. We can think of it like that's not exactly what's happening, but that's a good way of explaining it. Okay, so I've got a du dx part now, but have a look down here. I've got a y in terms of u, so I can actually also work out a dy du. So y on the left, u's on the bottom. I'm going to end up with a 6 down the front, u to the power of 5. So what I want to find out as my final answer, because I'm differentiating, I need a dy dx as my final answer. Oops. My dy dx, if I have a look at the rule above, is equal to dy du times du dx, which is equal to my dy du is over here, 6u to the 5, but I'm going to have to put something in for the u, because my u is x squared plus 1. So instead of putting in a u, I'm going to put in an x squared plus 1, and it's still to the power of 5. So that's my dy du times by my du dx, which is 2x. And what you'll find now is I don't actually have any u's in here. I've got my dy dx in terms of x, because I replaced the u with my original u value there. And what I'm going to end up with is for my dy dx, I can times the 6 and the 2, and I'm going to end up with 12x times by x squared plus 1 to the power of 5. Okay, so let's look at the second question here. We're going to use the chain rule to differentiate. 7 lots of 3x plus 4 to the power of 5. Again, it's a little more complicated, this one, because we've got a term inside, or a function inside another function. So the chain rule is the best way to do it. I've rewritten this as y equals 7 lots of 3x plus 4 to the 5, because that's what it is. And we want to find dy dx. In order to do that, we need a dy du and a du dx. So I need to assign a u somewhere. So I'm going to let the u be equal to the part inside the brackets. So u is going to be equal to 3x plus 4. So my du dx is this function differentiated, and I'm going to end up with just 3. Now my y is going to be equal to, I've got a 7 there. I've replaced this part inside with the u, so it's going to be 7u to the power of 5. So I've just rewritten y in terms of u, and now I can find out dy du, just as we normally would. 7 5s are 35, u to the power of 4. So I've got those two parts that are in the rule. So eventually I need to get my dy dx, but I need to do that in terms of dy du and du dx. I've got a dy du and a du dx. So let's put all that together. I'm going to write the rule out again. If you forget it, I think of it like this. So it's dy on the top, dx on the bottom, and the other partial parts go in there, du and du. That's what's happening. Okay, so let's work out what it is. So a dy dx is equal to dy du, which we've worked out over here, 35u to the 4. But what I'm going to do is I'm going to replace that u back in with the 3x plus 4. Okay, that's my dy du times by du dx, which is 3. And that gives me dy dx of equal to 35 times 3 is 105. 3x plus 4 to the 4 is my final answer for dy dx. If you want to pop that down there to make it a little bit neater as well, that's what we've got. Okay, let's go down a little bit further. Okay, powers of a linear function. Okie dokie. So what we're doing here is just writing this rule a little bit differently. So this rule looks a little bit different. It's only got a d dx there, and it's got a function in there. So normally, because our function is equal to y, for example, if we have a look up here, this is y. If we want to differentiate y, we want to find dy dx, we can actually just pop a d dx in front of it, because this is y, it's dy dx. It's another little way of just saying differentiate that function. So in this case, it's saying the differentiated version of this function, ax plus b to the n, is equal to, n comes down the front, take 1 off the power, then we differentiate what's inside here. So the differentiation of ax plus b is a. So the n that came down the front is times by that a from inside the brackets, and then it's n minus 1. And if you have a look back here to this rule up here, that's basically what we've done to get our answer. When we differentiated our x squared plus 1 to the power of 6 to get this answer here, what we've basically done is brought the 6 down the front here, taken 1 off to get our power, and we've times it by the differentiation inside the brackets, which is 2x. So it's 6 times 2x, and inside the brackets, we've taken a power off. So we can actually use that chain rule without breaking it up per se as what we've done before, as long as we remember what we want to do. Okay, so what we're going to do is use this rule and say that d dx of this function is equal to the differentiation of what's inside there, which is a, times by the power, which is n, and we can take 1 off the power and the bracket stays the same. And we can do that for each of these. Now, you could also go and do it like we did previously in the first question where we go u. So if I was going to do that, I'd let u equal to 4x minus 1, and I do it by parts. But if you understand how it works, we can actually work out dy dx straight up. So I'm going to say dy dx is going to be equal to, 7 comes down the front, and it's going to be times by the differentiation of what's in that bracket, which is 4. So it's going to be 7 times 4. Then my bracket stays the same. and I take 1 off the power. Okay, so what's that? 7 one's a 7, 7 2's a 14, 7 also 28. 4x minus 1 to the 6. Okay, let's have a look at b here. Y is equal to 1 over 3x minus 8. And we want to differentiate this, but we're going to need to put this into a format that we can use. So y is equal to 3x minus 8 to the power of minus 1. Remember, the minus throws whatever is in that bracket to the bottom line, and that's what we've got. So let's use this rule up here again. So to find my dy dx, again, you could use the chain rule and let u equal to 3x minus 8, and sometimes we'll have to. But in this case, I'm going to say, okay, I'm going to get my number from the front. I'm going to bring it down my number at the top, bring it down the front. It's minus 1. I'm going to differentiate what's in that bracket, which is 3. I'm then going to put my bracket back in, and I'm going to take 1 off that bracket. Minus 1 minus another 1 is minus 2. Sorry about my pen here. It's not very happy today. Okay, I cannot leave it like that. I'm going to leave it in a different form, and let's neaten it up. Minus 1 times 3 is minus 3. Now, this part here, the minus takes it to the bottom, and the 2's still in the power format. So it's minus 3 over 3x minus 8 squared. Okay, let's do c. We're going to need to write that in another format. We can't have the square root sign in there. So remember, the square root means we have a power of a half. Okay, the number on the top's the power, so it's to the power of 1, so it just stays as it is. The number on the bottom is the root, so it's a square root. Now, we're going to use the same rule as we've done for the other two. We're going to use this formula up here, which means to find dy dx, I get my power, and I bring it down to the front, so it's a half. I'm going to times that by the differentiation of what's inside that bracket, which is 5. I'm then going to pop that bracket back in, and I'm going to go a half minus 1, which is minus a half. And then I'm going to neaten it up. I've got a 5 on the top. I've still got a 2 on the bottom. The minus takes this down to the bottom, and the 2 tells me it's a square root or a power of a half of 5x plus 3. Okay, let's turn over the page and go down to the next question. What we are going to look at is we're going to look at differentiating this function here. Y equals 3 minus 5x cubed to the power of 7. So we are going to do it the same way as we did example 25, using the linear function short rule. We could also use the chain rule. But it says using a shorter setting out, so we're going to have a look at what it does there. Now, before we go any further into that, I'm just going to skip the question and we'll come back to that and have a look at this rule down here. Okay, so another approach to shortening the setting out is to remember a new standard form for differentiating a function. So it says d dx of the function. So remember, this is our function, or it's our y, so it's dy dx, and it just has y in terms of x. So to differentiate that, the n comes down the front. We differentiate what's inside there, and that's our f dash of x, and then we have our function, and we take 1 off it, which is what I've been doing up above. But what's really great about that formula is that is on your HSC formula sheet, and it's given to you. So you've got that there, but you'll still need to be very, very familiar with how to use it. So not only will you be given that in your HSC, you'll be given that in your Year 11 trials in a few weeks. So you need to be familiar with that and what's happening. Okay, so let's have a look up here at the question. So it says using a shorter setting out. What the question has done, it's given you the u there. Okay, if you get stuck doing it this way, you can go back and differentiate by parts, saying that dy dx is dy du on du dx. That's fine. But if you can see the shorter method and you understand it, it's a lot quicker to do it that way. So here's our y. So our dy dx, same as above. The 7 comes down the front. How they're doing it is, I did this bit next, but let's do it their way. 7 comes down the front. We write that bracket in that's there. We take 1 off the power, and then we differentiate what's in that bracket. So the 3 disappears, and we get minus 15x squared. The minus 15 times by the 7 gives us minus 105. The x squared is still out the front, and the 3 minus 5x cubed to the power of 6 is there. So that method is exactly the same as I've done up there for you. Let's look at number 27. Okay, differentiating. Y equals 3 minus 5x cubed to the power of 7 using the standard form above. Okay, here it's the same question. It's not giving you any way to work it out. You can work it out as you please. Let's go dy dx. Dy dx. So 7 comes down. 3 minus 5x cubed now takes 1 off the power. And then we're going to differentiate what's inside that bracket. So we're going to times that by minus 15x squared. We're going to get 7 times minus 15, which is minus 105. X squared, and then we've got 3 minus 5x cubed to the power of 6. We might also do it by parts if you'd like. Let's do another method in case you forgot that method, and it's often handy to use the other way. So let's let u equal 3 minus 5x cubed. So I've just let the part of the bracket be equal to u. So we would then have du dx be equal to minus 15x squared, which you can see is that part in there. Now, we know that y is equal to u to the power of 7 because I've called the part in the brackets u. So I can now work out dy du is 7u to the 6. So now we can work out that dy dx is equal to dy du times du dx. If you get stuck, you write dy dx down there and the du's are the opposites. Okay, my dy du is 7u to the 6, but I'm going to put in, instead of the u, I'm going to put my x's back in. So it's going to be 7 lots of 3 minus 5x cubed to the 6. That's my dy du times my du dx, which is minus 15x squared, which if you'll notice, it's the same as this line here. So if I multiply those out, I'm going to also get, oops, I've just moved that around a little bit. I'm also going to get my minus 105. Sorry, we just had a little mistake there with the spreadsheet. Where are we down here? So if I multiply those out, I'm going to get minus 105x squared, 3 minus 5x cubed to the power of 6. Okay, so no harder. Last question, more difficult. You just need to read it and see that it's explaining, wanting us to do something else. Okay, differentiate y equals 1 minus x to the power of 4 or to the power of 4. So we can do that. There's a part 2 and hence, which means we're going to be using our previous information. And hence, find the points on the curve where the tangent is horizontal. Now, we haven't been looking or thinking about tangents for quite a few lessons now, but remember, when we're finding our dy dx, our f dash of x, or differentiating, they're all the same thing, and they're all finding the gradient of the tangent. When a tangent is horizontal, a tangent has no slope, and we will have a dy dx equal to 0. That's what happens when our tangent is horizontal. So that's what we're going to do once we've differentiated. So let's use the quick method to differentiate. Dy dx is going to be equal to, let's put the 4 down the front. We'll go 1 minus x to the power of 4, now to a 3. And then we're going to differentiate what's inside that bracket. It's going to be times by minus 4x cubed. So if we join our minus 4 and our 4 together, we get minus 16. The x cubed comes out the front, and our 1 minus x to the power of 4 to the power of 3. That is our answer. Now, if you need to pause that and have a go at it, because I've gone a little bit too fast, please do that. Now, that looks like an absolutely horrid curve, but we are going to play around with it and see what we can do. Now, it's wanting us to find the points on the curve where the tangent is horizontal. So, we want, I'm going to write this in, and I would like you to write this in your books and in an assessment task, so that if we're marking you, we know that you understand what that means. So the tangent is horizontal occurs where dy dx is equal to 0. So what we want is we want minus 16x to the power of 3, 1 minus x to the power of 4 to the power of 3 to be equal to 0. Okay, now this is not a very nice question, particularly. It's a little bit harder. So I'm going to go down to the next page and we're going to have a look at what that means. So we've got minus 16x to the power of 3, and then we've got a 1 minus x to the power of 4, all cubed is equal to 0. Now, we haven't solved things quite this difficult when we were looking at quadratics or when we were looking at graphing curves, but we can look at what that means. So I would probably expect this would be more of an extension 1 question. So we're going to let this part equal 0, and we're also going to let this part equal 0. So I'm going to say minus 16x cubed is going to be equal to 0, and 1 minus x to the 4th to the power of 3 is equal to 0. So we're going to play around with these two things to see what our x values are going to be. Let's divide both sides by minus 16 here, and we're just going to end up with x to the cube equals 0. So if we take the cube root of 0, we're just going to get x is equal to 0. So we've got 1 point straight away. So that one's not too hard, and I would expect all of you should be able to do that. Now let's think about what's happening here. Let's take the cubed root of both sides. So I'm going to have 1 minus x to the 4 on this side. And you can do this bit on your calculator. The cubed root of 0 is 0. Okay, now I need to think. What have we got? I've got a difference of 2 squares. It's a bit of a harder difference of 2 squares, but 1 squared is 1, and x squared is x to the power of 4. So I've got a 1 minus x squared, 1 plus x squared is equal to 0. Okay, we can do this. Now, let's have a think again. This one I can't deal with just yet, but this one here, it's a difference of 2 squares again. So I can break that one up into a 1 minus x, 1 plus x, and I've still got my 1 plus x squared equals 0. Okay, what have we got? Let's set each to 0. So I'm going to have 1 minus x equals 0. So 1 equals x, or x equals 1. 1 plus x equals 0. So rearrange that to get x as minus 1. If you need to stop the video there and make sure that you can rearrange those, please do. 1 plus x squared equals 0. X squared equals minus 1. So in that case here, there's no solution because I can't take the square root of a negative number. Okay, I've just zoomed out a little bit. So I've got one value here, one value here, and one value here for x. So I think if you think back to our previous topics earlier in the year, you definitely can do this, okay? Let's have a look at what we now need to do. So let's go back up here and read the question. The question said to differentiate this function, which we've done, and hence find the points. That's our key word. We've found the x coordinates, we need the corresponding y point. So hence find the points where the tangent is horizontal. So remember, when we put those 3 points, we had x equals 0, x equals 1, and x equals minus 1. We substitute those points one by one into here, and we're going to get our y value. So let's do that right now. So we'll say, oops, sub x equals 0, minus 1, and 1 into y is equal to, let's have a look back at that function, 1 minus x to the 4, 4. We will get our corresponding y values. So let's do that. Stop it if you want to now and double check that you agree with me. But when x is 4, y is 1 minus 0 to the 4, or to the power of 4. 1 minus 0 to the 4 is 1 minus 0 to the power of 4 is 1. So our first point is 0, 1. Likewise, I can do that for when x is equal to 1 and when x is equal to minus 1. So we're going to end up here with 1 minus 1 to the 4th, or to the power of 4. So it's equal to 1 minus 1, which is 0 to the 4, which is 0. So we get the point 1, 0. And we're going to have here y is equal to 1 minus 1 to the 4, all to the power of 4, which is equal to 1 minus 1 to the power of 4 is going to be 1. So we're going to have 1 minus 1 to the power of 4, which is 0 to the 4, which is 0. So our point is minus 1, 0. Those are the 3 points. What did we find? What do they do? Those are the 3 points on that curve where the tangent is horizontal. And if you wanted, we could go back and plot that on GeoGebra to have a look at what that graph looks like. And that's the end. So you need to go back now to the HG and have a go at those exercises.